Hello, welcome back. This is Frederick again from Tektronix. Today's topic is going to be about the real-time spectrum analyzer and about what kind of things you can do with it and what does this POI really means. So I will try to do a simplified kind of drawing here. We have the RF going in and we have an ADC. And it's, I'm not so good in DC, and it goes directly as a stream. It always stream ADAs into the PEC. So in the PEC, there's one part, let's put it that way, that gives you I and Q data. There's one part that go to the DPX engine. And the way the DPX engine works, and I will try to do this really quick, is that you have a kind of a matrix. And if you search on our homepage, you can get more information about that. So you have a matrix like this, and it actually do a kind of, the FFT. And let me show you. So I changed it. Yeah. So the first FFT goes like this. The second one with blue goes like this. The third one, which is green, goes like this. And behind each of these, there is a kind of a counter, resetter, and timer. So inside here is a counter, timer, it's actually memory, mem, and reset. It's really hard. Okay. So in this case, we can see that we had 3 here, 3, 3, 3, 3. But here's only 1. Here's 2. Here's 3. And we build up a matrix related to this. There's 2, 1, 3, 3, 3. And this is what is used to kind of color code or do something, because we try to figure out what's inside. And then, of course, normal cases is that you have a frame. So there's also a frame. And then we update this. I think this is 50 milliseconds or something, which is a frame. So this is the basic how it works. It's stream all the time. There's no IQ data behind this. We go to a special engine. The engine drives this. We kind of count the number of hits, and we can control how we visually want to see this. So bear with me. So one of the questions we have is the POI, probability of intercept, and we stated 100% POI. And at something. In this case, for the RSA300, it's 100 microseconds. So today I want to show you how we can test this and how it works. So the question I got is that, okay, 100% 100 microsecond. Will I see a signal which is 1 microsecond? And if you know, you can calculate this backwards, that the sampling rate is 56 megahertz. So, okay. Enough of that one. Let's see what we can do, and I will try to verify that. So I connected a source. I put the center frequency around 300 megahertz, and the period at 100 milliseconds, and the width of 100 microseconds. So let's start with this one. And I have the program running here in the background. The first thing we do is just to check. We go for the DPX. I run this one. And in order to do this, there's some things we need to do. I need to set this up so I have the preferences show parameter readout. So this is what we're talking about today, this 100% POI at something. And you can see, when I'm recording, this will change a bit. So hopefully it won't be that bad. Okay, I will go here and I will actually close this window. Yes, don't save. And let's start doing this. So first of all, we need to verify the width of this. As you know, even if I'm triggering, this will show. So I will go in here and I will go to the navigator view. This is the first window I will open. I will also add the standard RF measurement is amplitude versus time. That's a simple measurement. So this is basically the setup I want. We're going to tweak this a little bit. The second thing I want to do here is put something called a split. So we can see, if I go down here, we can actually see a kind of tendency on these pulses. So I know the rep rate is 10 times per second, so we should have a couple of them. So the period 100 milliseconds. So you can see from time to time, even in this case now, it actually misses out some pulses. But anyway, bear with me. So now we need to trigger. So I go to the trigger menu. I put this as a trigger. I will go down here to minus, it should be around minus 70 or something. Here we go, and I put the length here to 100 microsecond. And yep, to make this a little bit easier to look at, I should tweak this like this. I'm gonna I'm gonna show the averaging here. It's a little bit easier to measure, and I add marker. So we have one marker here. Put it in the beginning. I try to put it in the beginning, and one marker in the end. So here we can see that it's roughly 100 microsecond, and you can see from this picture over here that we actually see it. And this, we probably don't need that anymore as it's triggering. So this is the setup. So what I'm doing now, I'm going to reduce this slowly down from 100 microseconds. I will put it now to start with 50. And you will see if I can clear this one, you can see it's 50. So I move this back and just do a check. My pulse is roughly 50. I'm a little bit, 50. You can see the pulse here. We can move in here, and we can just see, it seems to be so. But if you look on this one, we will actually start missing. So now the probability for us to see that is not 100% anymore. It's something else. So the 100% is making sure that you capture each single event. But from time to time, you will be able, depending on we do the FFT, you will see that one. So we will go further now. That's 50. So now we go down to 10. So this is 10. I do the same thing. I just clear this one out. I move this on so we can have a bit. Now we're at 10. So we're running at 10 now, and the POI is still like 100. You see it's running live, but we will miss. And you will see from time to time up here what's going on. I think there's one. So it's more and more random. But the question a lot of people ask, what is the limit of the RSA300 or 600? What's the limit? And depending on what you're looking for, this video is just to say, yes, you can see it, but it's not always seen. Remember that. So we're going to tweak this a little bit now. We're going to go down to 1. So we're now at 1 microsecond. So I clear this one up, and we're going to move this window here. So we just look at this one, and I move this one in the beginning. Just make sure that we have 1 and 1. Okay, so this is the text. So what's happening now, also the amplitude here is going to be weaker and weaker. So what we need to do here is tweak this a little bit. I go for this one, and this one, I go for amplitude scale, and I just make it a little bit like this. Probably can see it. And of course, I need a little bit more time. So now we can see each of them a little bit clearer here. And you see, we miss, but we're down to 1 microsecond. Now, I'm going to tweak as far as I can on this machine. I'm going to go down to, and let's measure what this is. So we're going to do clear, and I'm going to do, this one is probably better like this. So we're going to look at it like this. In this case, this is the kind of shortest I can do. Put this down here, put this one down here, and it's roughly should be like 300, 300 nanosecond. And you can see still in this back spectrum, you can see it. Now you will think that I kind of tricked this. I can prove that I didn't by doing one simple thing: remove the trigger. So now I'm free run. And free run and no free run doesn't matter. but you will not capture every event, you will capture less and less event. And there's a statistical formula to this. I hope you like this kind of video to see how good or bad things are, but this is reality. 100% POI guarantee you that you see every pulse. Less than that, you will not see every pulse. But as I proved to you, we go down to pulses of 300 nanoseconds or less. Thank you for this, and I hope you enjoyed this one.